Hello everyone, this is Veni Maditati. In this video, I am going to explain Vernier calipers. We can measure small objects using this Vernier caliper. This is how Vernier caliper looks. It is used to measure length, thickness and diameter. By using a normal scale, the least measurement that can be measured is 1 millimeter or 0.1 centimeter. Uh, this vernier caliper consists of a main scale and a vernier scale. Uh, this main scale is just like our normal scale, and this scale, which consists of very small divisions, this is called as vernier scale. A vernier scale contains very small divisions. Main scale is just like our normal scale, and each division in main scale is equal to 1 millimeter. It consists of two jaws. Those are upper jaws and lower jaws. These two were upper jaws and these both were lower jaws. By using the lower jaws, we can measure the outer dimensions of an object, and by using upper jaws, we can measure the inner radius of an object. These were the upper jaws, and these both were the smaller lower jaws. By using this lower jaws, we can measure outer dimensions of an object, and by using these upper jaws, we can measure the inner radius of an object. Here we can see a tail or stem. This is used for measuring the depth of an object. We use single formula to find either length, thickness or diameter. That formula is L is equal to MSR plus VSD into LC. Here MSR means main scale reading and VSD refers to Vernier scale division. It can be also called as Vernier coincidence, and LC is the least count. Least count is the one which can be measured, that is least measurement that can be measured by using any device, and the formula to find least count is 1 main scale division minus 1 vernier scale division. In every vernier calipers, the number of main scale divisions are greater than the vernier scale division. By using vernier scale division, we can find the measurements of very minute objects. If n Vernier scale divisions is equal to n minus 1 main scale division, we can write it as n Vernier scale division, that is equal to n minus 1 main scale division. From this we get 1 Vernier scale division is equal to n minus 1 by n main scale division. It means 1 Vernier scale division is equal to 1 minus 1 by n main scale division. We know that least count is equal to 1 main scale division minus 1 vernier scale division. So on substituting this here, and by taking main scale division as common, we get least count is equal to main scale division by capital N. Here capital N refers to number of vernier scale divisions. By placing any object between these two jaws, we can measure the diameter, length or anything. When there is no object between this vernier scale and main scale, then the zero of the main scale coincides exactly with the, this is how zero of the main scale coincides exactly with the zero of the vernier scale. When there is no object between these two scales, that is main scale and vernier scale, then zero line of vernier scale coincides exactly with the zero line of main scale. Now, as we have come to know that to find either length, thickness and diameter, we use the formula L is equal to MSR, which is main scale reading, plus VSD into least count. Now let us know how to find main scale reading. So for finding main scale reading, we should look on the main scale. This is main scale, and this scale, which consists of very small divisions, this is vernier scale. So to find main scale reading, first we look on the main scale. The place where the zero of the vernier stops on the main scale is your main scale reading. For suppose here the zero of the vernier scale stops at 2.1 and 2.2 in between the main scale. Now the main scale reading, that is MSR, will be 2.1. Simply select the preceding reading. If it was exactly, if the zero of the Vernier scale was exactly at 3 on the main scale, then your main scale reading will be 3. But in case if it is between 2.1 and 2.2, then you have to select the preceding reading. So as it was between 2.1 and 2.2, in that case your main scale reading will be equal to 2.1. This is how you find main scale reading. Now, how to find Vernier coincidence? To find Vernier coincidence, we should check on the Vernier scale, that is this scale, which consists of very small divisions. For Vernier scale, check on, for Vernier coincidence, check on the Vernier scale. Which line on the Vernier scale coincides exactly with the main scale? That will be your Vernier coincidence or Vernier scale division. Either Vernier scale division or Vernier coincidence, both are same. Suppose if we place any measuring object, now in this case where the main scale division and Vernier scale division exactly coincides, that will be your VSD or VC. Here 9 is exactly coinciding with 6 on the main scale. So your Vernier coincidence or Vernier scale division will be equal to 9. Remember that for Vernier coincidence you have to check on the Vernier scale. Which number on the Vernier scale exactly coincides with the number on the main scale, that will be your Vernier coincidence or Vernier scale division. And here it is simply 9, a number. You should not mention like 9 millimeter or 9 centimeter. You should just count it. However, we know that an instrument may contain error. Any instrument we measure, any measuring instrument contains some error. It may be due to error made by us while seeing, like parallax error, or it may be error made while constructing that particular instrument. So we should make correction to that error. Types of error are either having no zero error or having positive zero error or negative zero error. When there is no object between the two jaws, zero of the main scale coincides exactly with the zero of the Vernier scale. In this case, we don't have any error, but we have positive zero error and negative zero error. Let us see. Positive zero error. When the zero on the main scale, simply remember if Vernier scale 0 is right to the main scale, then we have positive zero error. That is, here we have main scale 0 and here we have Vernier scale 0. In this case, we have positive zero error. In order to uh, correct this error, we have to make negative correction. If there was positive zero error, then negative correction should be made. How can we know as it is a positive zero error? If Vernier scale 0 is right to the main scale, then it will be positive zero error and negative zero error. How to check negative zero error? If Vernier scale 0 is left to the main scale, here is your main scale 0 and here is your Vernier scale 0. In that case, we have negative zero error. For negative zero error, positive correction should be made. For positive zero error, we make negative correction, and for negative zero error, we should make positive correction. And here is a tip to remember. Remember, as this was origin, it is your positive x-axis and it is your negative x-axis. So positive x-axis, positive zero error. It means if you consider this as a main scale, then if it is right side, then it is positive zero error. If it is left, then it is negative zero error. Let us revise concept once again and we'll go to problems. Vernier caliper is a device through which we can measure small objects. Vernier caliper is used to measure length, thickness and diameter. By using normal scale, the least measurement that we can measure is 1 millimeter or either 0.1 centimeter. And Vernier caliper consists of two scales, which is main scale and Vernier scale. Main scale is just like our normal scale, and Vernier scale is the one which consists of very small divisions. By using this lower jaws, we can measure the outer dimension, and by using this, we can measure the inner dimensions. Here, it consists of a tail which is used for, this is called as tail, which looks like a stem. This is used for measuring the inner radius. Sorry, this is used for measuring the depths. So we use a single formula to find either length, thickness or diameter, that is L is equal to, either here L may be length, thickness or diameter, MSR plus VSD into least count. MSR means main scale reading, VSD or VC, Vernier scale division or Vernier coincidence, these both are same. And LC, least count. Least count is the least measurement that can be measured by using any device, and the formula to find least count is 1 main scale division minus 1 Vernier scale division. In every Vernier caliper, the number of main scale divisions are always greater than the number of Vernier scale division. See here, the number of main scale divisions are greater than the number of Vernier scale divisions. And if n Vernier scale division is equal to n minus 1 main scale division, then 1 Vernier scale division is equal to n minus 1 by n main scale division. And from that we can find another formula for least count, that is MSD by n. Here n refers to number of Vernier scale division. And when there is no object between two scales, then zero line of Vernier scale coincides exactly with the zero line of main scale. This is how. Here the zero line of main scale and Vernier scale are coinciding exactly as there was no object between these two scales. Now, how can we find MSR? To find MSR, MSR means main scale reading. We should look on the main scale. The place where the zero of the Vernier stops at the main scale is your main scale reading. That is, if the zero of the Vernier is stopping here at 2, then 2 is your main scale reading. If it stops at 3.7 and 3.8 like that, then your then your main scale reading will be 3.7. You have to take preceding reading. The place where the zero of the Vernier stops at the main scale is your main scale reading. If that reading is between 2.1 and 2.2, then your main scale reading will be 2.1. Simply select preceding reading, that will be your main scale reading. And how to find Vernier coincidence? For Vernier coincidence or Vernier scale division, both are same, Vernier coincidence or Vernier scale division. You have to check on the Vernier scale. Which line on the Vernier scale coincides exactly with the main scale? That will be your Vernier coincidence or Vernier scale division. For Vernier coincidence, you should check on the Vernier scale, and for main scale reading, that is for MSR, you should check on the you should check on the main scale. For example, Vernier scale division is equal to 6. It is just simply a number. You should not mention millimeter or centimeter. You should just count it. However, an instrument may contain an error. That may be positive error, negative error or zero error. For no zero error, when there is no object between the two jaws, zero of the main scale and the zero of the Vernier scale coincides exactly. In that case, there will be no zero error. In this case, there will be no zero error. And for positive zero error, if the Vernier scale 0 is right to the main scale, then you have the positive zero error. See, in this case, Vernier scale 0 is right to the main scale 0. So here we have a positive zero error. And for positive zero error, negative correction should be made. For negative zero error, we should make positive correction, and if Vernier scale 0 is left to the main scale, then it is said to be negative zero error, and for it positive correction should be made. Now let us go through few questions. Coming to this question, n divisions of main scale are equal to n plus 1 division of Vernier scale. If each division on main scale measures a units, then find least count. Simply write this statement into mathematical form. Here they have given that n division of main scale are equal to n plus 1 division of Vernier scale. It means n main scale division, n MSD, that is equal to n plus 1 Vernier scale division. N MSD is equal to n plus 1 VSD. Now 1 VSD is equal to n by n plus 1 MSD. We know that least count is equal to 1 main scale division minus 1 Vernier scale division. So by substituting this 1 Vernier scale division is equal to n by n plus 1 here, and by taking MSD as common, we get least count is equal to MSD by n plus 1. But here they have mentioned that if each division on main scale measures a units, that means 1 MSD is equal to a units, so least count is equal to a by n plus 1. And now coming to second question, the Vernier scale used for measurement has a positive zero error. They have mentioned error as 0.2 millimeter. If while taking a measurement, it was noted that 0 on the Vernier scale lies between 8.5 centimeter and 8.6 centimeter, and Vernier coincidence or Vernier scale division, that is equal to 6, then the correct value of the measurement is. Here they have mentioned that positive zero error, that is 0.2 millimeter. Here there was important point to remember. If they have mentioned you positive zero error and it was given in millimeter, then the negative correction will be simply while you convert it into centimeter, it is 0.02 centimeter. This will be your negative correction. This is only when in the question they have already mentioned that it was in millimeter. So now negative correction is equal to minus 0.02 centimeter. We know that L is equal to MSR plus VC into least count. So as here, as they have mentioned, Vernier scale lies between 8.5 centimeter and 8.6 centimeter. For main scale reading, we should always check preceding value. So 8.5 will be your MSR, and your Vernier coincidence they have already mentioned as 6, and your least count is 0.01 centimeter. Now the answer is 8.56 centimeter. But as here we have a positive zero error, we should make negative correction for it. It means from the answer we should subtract with the negative correction, that is minus 0.02 centimeter, which is equal to 8.54 centimeter. Least count for Vernier scale is 0.01 centimeter if they haven't mentioned in the question. Now coming to last question. In a Vernier caliper, 10 Vernier scale division is equal to 9 main scale division, and 1 centimeter in main scale is divided into 10 parts. While measuring length of a block, the 0 of the Vernier scale is just ahead of 1.8 centimeter mark, and fourth division of Vernier scale coincides with the main scale division. Then you should find the length of the block. Here already they have given question in a mathematical form, that is 10 Vernier scale division is equal to 9 main scale division. Now 1 main scale division is equal to 0.1 centimeter, as they have mentioned in a Vernier caliper. 10 Vernier scale division is equal to 9 main scale division, and 1 centimeter in main scale is divided into 10 parts. That is 1 centimeter is divided into 10 parts. It means each division is 0.1 centimeter. So your MSD will become 0.1 centimeter. From this you get VSD as 9 by 10 MSD, and again you know that least count is equal to 1 main scale division minus 1 Vernier scale division. So from this you can calculate least count. And here they have mentioned, while measuring length of a block, the zero of the Vernier scale is just ahead of 1.8 centimeter mark. It means your main scale reading is equal to 1.8 centimeter, and fourth division of the Vernier scale coincides with the main scale division. It means they have mentioned VSD, that is Vernier scale division, or VC, that is Vernier coincidence. Fourth division of Vernier scale coincides with the main scale division. It means your VSD is equal to 4. Now by using this formula, L is equal to MSR plus VSD into LC. By using this we can find the length of the block, and substituting this MSR is equal to 1.8 plus VSD 4 into least count 0.01 centimeter. We get 1.84 centimeter. Hope you liked the video and you are clear with the concept. If you have any doubts regarding this, you can ask me in comment section, and for session PDF, if you comment me, then I'll provide you that notes. Thank you for watching my video, and subscribe my channel for more videos. In my next video, I am going to discuss about screw gauge. Thank you for watching.